All right, this is going on page 81 when we are done. So we're still talking about the law of sines, right? Same rule, same little proportion that we did yesterday. So this says the same thing as it did. Then we're going to look at oblique triangles, so we're not doing right triangles. Still law of sines. Yesterday we looked at angle, angle, side, and angle, side, angle. Today we're going to look at side, side, angle. But again, law of sines is law of sines. So this is the sine of A over A equals the sine of B over B equals the sine of C over C. But more important than knowing that exactly like it's written, because remember, it could be the reciprocal of it as well. It's the overarching concept, which is it's the sine of an angle over the side across from it equals the sine of an angle over the side across from it. That's the way the proportions work. Okay. Yesterday we looked for missing sides, so when we got an answer, that was our answer. Today we're going to use this to find a missing angle, but then there's some other stuff we have to do because it's the ambiguous case. So in geometry, you use these two to prove triangles congruent. We could not use this because it's the ambiguous case. Let's talk about what that means. So if I have, so SSA, that's different than SAS. SSA means I have two sides and an angle that's not included. So let's say I have this side, and this angle. Okay, so that's two sides and an angle that's not included. That means I don't know what the measure of angle A or C is, or the length of side C, and those could change. What I have marked, that's set in stone. So if I gave you an angle and two straws, because we do this activity in geometry, there is more than one triangle we could make with this. I could make this one, or I could make this one. Okay, so you see the original one and then this green one that still has the same two side lengths and the same angle measure. And would you say those two triangles are very different than each other? Yes? Okay, one has a lot more area than the other one does. So that's what makes it the ambiguous case, because this side length could swing back and forth, and I don't know which triangle we're actually making. Like, is the length of side C this length, or is it this length? Is angle C this one, or is it this one? That type of thing. Okay, does that make sense to you? So that's what makes it the ambiguous case. There's more than one option. Whereas if I have two angles and the included side, there's only one way to actually draw that triangle. Okay, so what that means for law of sines is this. If I'm looking for the missing angle, so let's say that I'm looking for angle A. So in the big triangle, here's angle A, right? In the little triangle, this is that same angle because it's across from side A, right? Two very different angles. Would you agree with that? So I have two options for my angles. Now look just at this little triangle right here. What kind of triangle is this little triangle? Oh, I'm sorry. This should have 3 marks on it because it's different. That was my whole point, was that these two are different. This little triangle here, what kind of triangle is that? Possibly. It kind of looks like it. I'll give you that. But we don't know for sure that this side length is the same. So you're on the right track. We know for sure that it's what? Isosceles. Very good. So it's an isosceles triangle, which means that since these two sides are congruent, these two angles are congruent, right? So when I find my missing angle, it could be this one or it could be this one. But since these two are the same, you can see the relationship between the two angles the same. How are these two angles related? They add up to 180. Yes, thank you for not saying what I get a lot of times, what I got last period is they equal 180. I said, okay, so this one's 180 and this one's 180. No, they add to give you 180, which is what you mean. I know what you're trying to say. I know what you mean when you say they equal 180, but we got to be careful with our words. What's the fancy word for saying they add to give me 180? Starts with an S. Supplementary. Yes, I heard it. Supplementary. Okay, so they're supplementary angles, which means I could get this one or this one, but either way, my two options would have to add to give me 180. Make sense? Because all that's going to come into play here in just a second. All right, so again, yeah, the difference, and this was a question at the end of class last period, which was a very good question. The difference between what we're doing today and what we did yesterday, it's still law of sines. We're setting the proportions up the same. If we could set them up yesterday, we can set them up today. The difference is yesterday we found missing sides, today we're finding missing angles. So it's just solving for a different part of it, but the setup and all the concept is the same. But we got all this extra stuff that goes along with it here. Okay, so if we are finding angles with law of sines, because we'll also do it with law of cosines, but it's not this complicated. This isn't complicated. It's not this involved. So we're using SSA. So it says, watch out, watch out. When finding angles, it's possible to have one solution, two solutions, or no solution. Okay, so we're going to find our answers, and then we have to check them. Okay, sometimes we find answers, it is what it is. Sometimes we find answers, and we have to see if they're extraneous answers or not. Kind of like when we solved exponentials, it was what it was. When we solved logs, we had to try and check to see if they were extraneous. All right, so let's talk about sines. So here's my unit circle. You can pretend like it's actually centered, and it's a better circle than I usually draw. So it says the sine function always has blank. All right, so tell me, what is the sine of 0? 0. What does the sine of pi have? 1. Can I have a sine value that is greater than 1? No, that's the largest y value I'm going to have, right? Which means that the smallest sine value I'll ever have is what? Negative 1. So the sine function is always between negative 1 and 1. Those are my only options. So that 1/2, square root of 3 over 2, all that stuff, that's all between negative 1 and 1. All right, and then we know that angles with a positive sine function can lie in quadrant, well, everything's positive in quadrant 1. Where else is sine positive? 2, okay? So sine is positive in quadrants 1 and 2. So when we solve this, our calculator is going to give us an answer. Boom, we get us one angle. So we have to figure out how to find the other angle. So let's think about what we do on the unit circle. Now, we're going to be doing everything in degrees, but when I talk about the unit circle, I think it makes a little bit more sense to you in radians, as it should at this point. So let's say that we have pi 6, okay? So I'm here at pi 6. If I want the second quadrant pi 6 angle, the way I taught you to do it when we were first learning it is we go to pi, that would be 6 pi 6, we back up 1 to get 5 pi 6, right? So I always go to the axis and back up 1. Because this is pi, what is pi in degrees? 180. So it's like going to 180 and backing up. So what is pi 6 in degrees? 30. So it's like saying, okay, this is at 30. If I want my second quadrant 30-degree angle, which doesn't make as much sense as second quadrant pi 6 angle, but you know what I mean, the other angle that we need, we'd go to 180 and subtract 30 and get to that same place. Does that make sense to you? So it's the same concept, which means when we get an angle, the calculator spits it out for us. To get the other possible angle, we just subtract from 180. Okay. A couple of other things we need to keep in mind as we go through this and check our answers. The sum of the angle measures in a triangle is always what? 180. So these answers are both 180, but for two very different reasons. Okay. And then there's no triangle can have two blank angles. There's two correct answers here, but I'm only going for one of them. So if you give me one of them, you're not necessarily, the one I don't want, you're not necessarily wrong, but we'll talk about it. A triangle can't have two what kind of angles? Right, and that's correct, but we're not talking about right angles, so that's why it's not. So the other one is obtuse. Okay, can't have two obtuse angles. Right, and we'll talk about that as we go through. Right, any questions at this point? All right, so we have to draw our triangle, just like I believe in Delta Math, it's making you do that. It doesn't matter that it's to scale. Most of the time, mine look the same every time I draw them. All you really need is something to label. It's fine if it's not to scale. Just remember it's not to scale. You can't go by the way it looks. So we have triangle ABC. So, all right, this is triangle ABC. And even though I know some lengths and angles, I don't care about it being accurate, really. If you try and make them accurate, sometimes it's hard to label. So just make them whatever. Angle A is 60 degrees. The length of AB is 30 inches. The length of BC is 27 inches. And I want angle C, I'm going to call it theta. So I'm going to do the same thing we did yesterday. We're still using the law of sines. I'm looking for angle C. It's across from 30. So I always take the sine of the angle. So the sine of 30, no, that's not right. Sine of theta over 30. See, it's tempting because we usually use 30 degrees. I was showing you what not to do. Make sure you take the sine of the angle because it is easy to do the wrong thing. That is equal to, then I set this one up, sine of 60 over 27. Everybody good with all that so far? Okay, so I'm trying to get theta by itself, which means first I have to get the sine of theta by itself. So I can do that by multiplying both sides by 30. So I get the sine of theta is equal to 30 times the sine of 60 over 27. Now, we could simplify this, but we don't care, and we're not going to. Just because you can doesn't mean that you should. We're going to let the calculator do everything. All right, so I need theta. How do I get sine away from theta? The arc sine or the inverse. Good. So I'm going to have theta equals the sine inverse or arc sine of 30 times the sine of 60 over 27. I think maybe I heard cosecant, so let's talk about that. I don't know who said it. If you said it, that's okay. I want to remind you that inverse and reciprocal are two completely different things. Cosecant is not the reciprocal, no, sorry. Cosecant is not the inverse of sine, it is the reciprocal. Here we want the inverse, okay? So then double check that your calculator is in degrees. Type it in just like it is. I would use the fraction button for this part. And get your angle. It's only going to give you one. Make sure that you get, and actually be pushing the buttons. I'm going to give you the answers, but I want to make sure that you're getting this. If you're not getting the right answers, we need to figure out if it's something wrong with the calculator or if something wrong with you. All right, so did we all get 74.207? Good. Okay, so that's one possibility. I need the other one. What do I do with this angle to get the other one? Subtract from 180, which means on these calculators you can just do 180 minus what? Answer. It's the easiest way to do it. Never ever type a decimal, but rounded decimal back in. All right, so we have two answers. Doesn't mean that there are two answers. Okay, so we have to check them. And here's how you check them. Because if you get one, you'll get two every time because all you're doing is subtracting from 180. Here's how we check them. I need to know if these angles are going to work in this triangle, meaning that we know that there's 180 degrees in a triangle. And I don't have a clue what angle B is, and I don't really care. But I need to know if whatever I got for theta, when I add it to 60, is there still going to be room for another angle? So we'll take 60 plus, and we don't have to do that. You don't even need the calculator for this. It's 60 plus this angle, so basically plus 74 something. And all we care about is when I add those two together, will it be less than 180? Yes. The actual value is irrelevant. That's why I said you don't have to type it on the calculator. It's just, yes. When I add those together, it'll be less than 180, which means there's room for a third angle there, okay? Then I still take 60, and I add it to the other one, 105 something. Don't care about the actual value. But when I add that together, that's like 165 something. That is less than 180. So I'm good. Both answers work. There are two possibilities here. Okay. So you set it up, you solve it, pretty much just like we did yesterday, except we got to use the inverse. You find the other angle, and then we have to check them and just make sure the one that you're given plus the one that you found are less than 180. If it's not, then it doesn't work. Okay. Any questions about anything? We all good? All right, let's look at number 7. So ABC. The angle C is 89 degrees. The length of AC is 34 meters. The length of AB is 26 meters. And I'm looking for angle B. All right, so go ahead and set up your proportion. And that's what we should get. Make sure that's what you got. We agree with that? All right, so then we multiply both sides by 34. So the sine of theta equals 34 times the sine of 89 over 26. And then because we're looking for an angle, that's when we use the inverse. So theta equals the sine inverse of 34 times the sine of 89 over 26. Okay. I'm going to go ahead and type that in. What do you get? Caden, what'd you get? You got an error. Did anybody else get an error? Yes. The way you looked at me and smiled, I knew you didn't want me to ask you. That's why I asked you. Because okay, so we got an error. Now, when you get an error, what's the first thing you think? I messed up, right? Okay, so, is that what happens sometimes? Yes. So if you get an error, you should double check that maybe you did it right. Okay, and let's see if we did it right. So what I want you to do now is just clear it, get back to your home screen, and then I want you to just type in this fraction. Just the fraction, not the sine inverse part, just this part. And you should get 1.3074, right? Something like that. Okay. So because we don't find this first, because it's not necessary to do that and then take the inverse, but I'm having you do that here because I want you to see what it is. So we don't really have an idea of what this is. So we're trying to take the sine inverse of this number. Why do you think we're getting an error? It's over 1. Your sine values that you're going to, so like the sine inverse of 1/2 is pi 6 because the sine of pi 6 is 1/2, right? So you're trying to take the inverse of a sine value that can't exist. So your answer here then is just no solution. So if you're not confident enough that because you got an error because it's no solution, because honestly, you could have gotten an error because you accidentally hit the wrong key or pushed the wrong button or whatever. I mean, that happens. If you look at just what this is here, I don't know why that looks like a colon, then you can, just make sure you can kind of tell yourself that, you're good on what the answer is. Okay, does that make sense? So that's how you get no solution. If you're trying to take the sine inverse of a value it's greater than 1 or less than -1. Okay, we good on that? All right, good deal. Let's look at the next one. All right, number 8. So here's my triangle, A, B, C. So the measure of angle C is 102. My triangle is clearly not to scale. I don't care, not worth redrawing. All I'm trying to do is label something. The length of AC is 21 yards. The length of AB is 24 yards. And I'm looking for angle B. Okay. So the setup's the same as what we did on the last two and what we were doing yesterday. This angle is across from 21. So I'm going to take the sine of theta over 21 equals the sine of 102 over 24. Get sine by itself by multiplying by the denominator. So the sine of theta is equal to 21 times the sine of 102 over 24, which means theta is the sine inverse. Type that you should get an actual angle this time. So if you get an error, there's the problem. But find both of your angles. So after the calculator gives you the first one, how do we get the second one? Subtract it from 180, okay? Then, are we done? No, we got to check them. We take the angle that was given to us, which is 102. We add it to 58 point whatever. The actual value doesn't matter. When I add those two together, that's less than 180, so that one works. When I take 102 and I add it to the 121 angle, that's greater than 180, so that's bad. So that angle doesn't work. It's only this one. So as far as showing your work, you have to show me that you got an angle, you found the other one. And then if you decide it's no good, then you mark it out. If all you have is this answer right here, I'm not giving you credit because I don't know that you know what you're doing. To me, that looks like you just got this and you stopped, right? And you just got lucky because that was the only answer. So you find them both, and then you check them, and then it's just that one. Okay, we good on that? What questions we got? We don't need to do any more examples, do we? It's the same thing over and over again. Okay. All right, good deal.